Hi there, folks, and welcome to another update about the ongoing situation in Iceland. Today is Friday, November 24th. It is almost noon here, Mountain Standard Time, which would make it about 7 p.m. or close to 7 p.m. there in Iceland. Hope you're doing well. I want to apologize for the few couple day break there in my updates. Wednesday here on campus, we had a scheduled power outage, and so the power was out all day, which prohibited me from getting into the office and doing my routine here. And then Thursday here in the States, it was the Thanksgiving holiday, so I was with family and friends enjoying the day there. But it did nicely coincide with a pretty good lull in the activity in Iceland, so you really didn't miss a whole lot over the last couple days if you weren't paying attention to things going on there. Today, what we'll do is update you a little bit because there have been some developments in the area, and I want to look at just a possible future for the area, some interpretations of the data that I want to share with you. I will probably not do any updates this weekend unless there's something significant. We'll be out of town visiting some family, but I'll bring my laptop in case something significant goes on. But look for continued field-based videos, the typical videos that I post. I'll continue to push some of those out. I still have quite a few of those on the queue. And next week, I will be sure to do another update with you as well as a viewer question and answer session. There's a lot of people that have been enjoying those, so appreciate it. Let's go right to some of the data for the earthquake. And let's look first at, let me close this window here. This is from the Met Office, and this is a plot. And I apologize if it's a little fuzzy. This was the best version that they had out there. But this is two graphs showing earthquake numbers over the last week. So on the left side of both graphs, it's November 17th. And then on the right side, it's today, November 24th. And what you'll see here, the top graph shows earthquakes, I believe, by hour, and the bottom graph shows total number of quakes for that given 24-hour period. And no matter which graph you're looking at, you can see that the earthquake numbers were quite high at the beginning of this period up until about the 20th or so of November, and they started dropping. The 21st and 22nd were quite low. This may be partly due to the fact that there was a large winter storm that was impacting Iceland that inhibits the seismometer's ability to detect some of the more sensitive earthquakes. So we might be seeing a significant drop there based on that. But nonetheless, the storm has since passed, and we can see that that still the total number of quakes happening has dropped pretty significantly. And so that's good news for our good friends in Iceland that we've got this total number of quakes dropping a bit. Let's look at some of the other data that's out there. Let's start with the just the raw data going on right now. Let's go to the last 24 hours here. And this is for all quakes magnitude 0 and above. And you can see there's really not that many, especially compared to some of the other plots we've looked at in the past. So they're still nicely defining this northeast southwest trend where we believe this intrusion of magma has occurred. But all these quakes are pretty small, nothing above magnitude 2. If we isolate for just magnitude 1 and above, maybe 10 or so, and that's over the last 24 hours, again, putting all the quakes on. And if we look at the last, let's say, 12 hours, again, only like maybe half a dozen or so earthquakes. If we go even like less than that, last 6 hours, 3. And so there's not a lot of seismic activity happening. It's still happening, but at a much lower frequency and magnitude than what we've seen in the past. So that's good news as well. If we go back to the Met Office update and just look for some of the highlights in their text update for today. So they talk about the quakes decreasing. The seismic activity continues to decrease. But at the same time, we've got GPS measurements showing that the uplift near the power plant at Svartsengi is still ongoing. And so even though we're getting reduced earthquakes to the east at the magma intrusion, we still have GPS measurements showing that there's uplift happening back over towards the power plant. And they say here, let's see, considering the latest interpretation of all the data, the likelihood of a volcanic eruption at some location along the length of the magma intrusion persists. So we're not nearly at a point now where we can say the threat has passed and the possibility of an eruption has gone to zero. We're not at that point yet. It's possible that magma could emerge in the area near Hagafell. We've talked about that previously. Um, the likelihood of an imminent volcanic eruption diminishes with time. So as we get seismicity dropping and less signal that more magma is moving into the system, the chance of an eruption drops. And I know at the beginning of this thing 2 weeks ago, I was probably at 70, 80%. My probability has changed over the time. If I had to put a number on it today, I'd probably say like 40%, somewhere in that range. So less than 50-50 chance based on all the signals and signs we're seeing up to this point. Again, this is good news for the folks in Iceland, at least in the short term. Let's see what else we have here. Let's look at some of the GPS data. And so remember, this is a map that shows different stations. We're going to look at two specific stations here. We're going to look at first the one near the power plant, which is this station, and then we'll look at the one closest to Grindavik. And so you can see what these plots show is this goes from August through September, October, and into November. So this is a little over 3 months, or about 3 months worth of data. So everything pretty much background level, no movement, slight uptick as we get into November. And then they've drawn a dramatic blue line here because that was November 10th, which was probably the most exciting, I suppose, but also terrifying and dramatic day in this period of unrest was November 10th. That's when we had the strongest shaking and earthquake activity near Grindavik. It's also when we thought the eruption was imminent, like it looked really much like an eruption was going to take place very soon. So you can see continued northward movement, but not nearly as steep as it was previously, but there's still some deformation going on by the power plant. On the east-west plot here, the middle one, you can see the movement still to the west, but again, it's tapering off, so we're not seeing those the GPS signal and data pointing to as much rapid or persistent movement of the ground as we saw otherwise. But we still are seeing uplift. So if we look at the last plot here, there's where everything subsided and dropped, but we're seeing continued uplift. And notice the trend or the slope of this line since November 10th is pretty much the same. So until we see this thing maybe start to roll over and present us with a more gentle slope, I think that's why we still are very much concerned and on guard with the situation. If we look at the data for Grindavik, the main one I want to point to here is the uplift data. So here we are going through October, slight uplift heading into November, and then as that magma intruded and formed that northeast-southwest dike, you can see the rapid decrease in the elevation. But now notice that as we get to the tail end of this thing, the last week or so, it's largely stabilized. So we're not seeing continued subsidence or the ground moving downward in Grindavik. And so that's good news. So some of those cracks, I've heard that they've started to fill some of the big cracks in town with earth materials. So that's great news as well. So lots of good signs in terms of there not being an eruption, but the uplift data here is still the thing that we're tracking and taking a good look at. And then this came from a viewer. This is from a viewer in Norway, a fellow geologist in Norway who sent me this, and I appreciate it. He was able to get a little further into some of the websites and places I didn't know existed. And let's focus on this bottom plot here. This actually shows earthquake activity over the last 18 months or so. So basically, the color change is just because as you go from blues to reds, they're more recent. So that's pretty simple. The higher the dot is up on the graph, that would be a larger quake. And I believe they've got all the magnitude 3s and above shown with stars. That's usually the way the Met Office delineates those quakes. And so we can see lots of earthquakes happening in July 2022. And then boom, you can see this dramatic spike here. That coincides with that eruption in August of 2022. I was lucky enough to go visit that eruption in that area. So you can see that eruption coincides with this seismic data. Then that eruption ended after a couple of weeks. seismic data going back to more or less background levels, a couple big ones, but just, lots of little earthquakes. And then here, about a year later, in July 2023, was our Lichtlichruter volcanic eruption, a little bit north of the previous one in 2022. But you can see again the earthquake spike, higher magnitude quakes, and a lot of concentration around that earthquake activity. And then we get to the current period we're in now. And notice this is a little bit more, not just, I wouldn't say messy, but more protracted, right? Both of these eruptive periods formed nice concentrated spikes in seismic data that quickly accelerated leading up to the eruption within a week or so, and then quickly trailed off again on the backside. And here we see a similar spike on the front side with similar magnitude and nearly as many earthquakes, but then it kind of just coming up and down and then now it's kind of trailing off a little bit on this backside. Lots of ways to interpret this, but one interpretation might be that we came over the last 2 weeks as close to an eruption as you can without having one. And we could still have one, of course, that's still on the table. But based on the seismic signals and what we've seen in these two previous eruptions, that's one possible way to interpret this, is that you broke enough rock, you brought enough magma up towards the surface that, for all intents and purposes, you probably should have had an eruption, but for whatever reason, the magma just did not erupt and make its way to the surface. So I found this plot to be kind of interesting. So what to make of things moving forward? So now let's get into the interpretation kind of phase of things. I read this paper here, this short article on eruptible magma, and I'll put a link in it in the description if you want to go through this. But basically, and we've talked about this before, that not all magma is eruptible. I think we have this idea that underneath these volcanoes there's this vat, this storage chamber of liquid melted rock that's just primed and ready to blow to the surface and cause all sorts of mayhem. It's really not that way. Think of it more as a spectrum between very fluid magma that is hot and possibly primed and ready for eruption, and at the opposite end of the spectrum we would have nearly completely solidified magma. So it's mostly crystals, right? And then in between you have different proportions of magma or melt to these crystals. And what they've done here, and this is just some great graphics, and it was pretty well laid out, I thought, and it's a short article, so it's an easy read. Basically, they're saying that you need at least 40% melt. So of your volume of material, at least 40% of it needs to be liquid, melted rock, actual magma. And the other percentage is, of course, crystals that have formed in that material, but that percentage of crystals needs to be under 60%. If you can get into that range, which is kind of in this top of this funny diagram here, then you have what we're calling eruptible magma. Doesn't mean that it will erupt, it's just that it could erupt. It's primed, it's the type of magma that does make its way to the surface in an eruption. And at the other end of the spectrum, if your content of material is 60 to 80%, or excuse me, 60 to 100% crystals. So if it's mostly solidified and you have very little portion of melt, less than 40%, then it's basically ineruptible. It is not going to erupt. And magmas constantly vacillate between these different, at all points in the spectrum. It's just constantly changing. It's this dynamic scenario. And so I found this little graph here to be kind of helpful as well. So if you look at temperature here from high to low, and then this is time, and now imagine any given magma body. This is sort of hypothetical, but it could be the one we're looking at in Iceland, where what we saw was, maybe the magma becomes eruptible because it gets injected with more magma, its temperature increases. So if you increase the temperature, you're turning some of those crystals back into melt, they're melting. And so you've got a system that could erupt and may erupt, but then over time, as that material cools, you're turning more of the melt into crystals, and now you drop below this threshold where the magma is no longer eruptible. And they use the analogy of a sponge, which I think is a clever analogy in terms of visualizing this sort of system. Then you could get an injection of more magma, which might raise its temperature, so it's possibly eruptible, but it still has some crystals, and then you could see it drop, and so on and so forth. And so this is a fun way to think about how this whole system might play out, because we're really in a situation now where, okay, it's looking less likely that we're getting an eruption, but now what? Now we're in this sort of wait and see weeks, months, and possibly years from now as to what this area is going to do. And this is where some of our decisions, or the decisions being made by the government and the public officials in Iceland, this is where it gets really tricky and hard. Because really what we're dealing with now is what's called acceptable risk. So has Grindavik always had a risk of volcanic eruptions? Yes, 100%. You can see the craters, you can see the lava flows that have poured down towards the coastline. There is no doubt there has always been and always will be a risk of volcanic eruptions in this region. But what we have now is looking at it in terms of acceptable risk. So we know there's a risk here. How much of a risk are we willing to accept as individuals possibly, or as a society or a country in this case? So how much risk is too much? Right now, based on following the science and what's happened over the last 2 weeks, we're saying it's not an acceptable risk. We're asking people to stay out of their homes, at least during certain parts of the day. We're either fully evacuated or we're partially evacuated. But at some point, if this continues to drop, at what point could this be something where you allow people back in and actually allow them to come back into their homes? And that's the tricky thing. I think I read one of the civil defense folks' quotes was something to this effect. He basically said, we need to have a situation where there is no to little, and who knows what little is, chance of a rapid evacuation. So if we can, looking at the data and the situation here, if we can determine that the likelihood of a very rapid evacuation of all the citizens here is not likely or very unlikely, that would be an ideal scenario where we would let everyone kind of come back in. But right now, with the uplift and some of the things happening, that's less likely to be the case. So we'll just have to see. They did allow people into their homes today, I heard, from 9 to 4. So earlier today, residents were allowed to go back into their homes for a sizable portion of the day, not just grabbing their stuff and leaving again. So that's a great step. But really, moving forward, it's tricky. We would like to be able to forecast these eruptions just like we do the weather. If you think about how we forecast the weather, we have all sorts of satellite data and other data for the atmosphere, humidity, air temperature, pressure, wind, just all this data that we can then put together, use computers to help model and simulate what the weather's going to do. And generally we get it right. Occasionally it's wrong, right? But generally the weather forecast most of the time turns out to be pretty accurate. Now imagine what we're trying to do with this volcanic system. All the data is underground. Everything we would like to measure and know about this thing, how much of its crystals, how much of its melt, is it eruptible magma or non-eruptible magma? Where are the earthquakes happening exactly and what's causing them? Is it magma movement? Is it stress and cracks in the rock? All these things that we're really trying to get a handle on, but we don't have the direct data. We don't have a clear picture about what's happening in the subsurface. Furthermore, with the weather, you can monitor it continuously because it's always happening 24/7. Magma movement and eruptions only take place, during these kind of pulses, right? It kind of ebbs and flows a little bit. And so it's a really tricky scenario, this idea that we're trying to put all this together and figure it out. So I'm hopeful for the folks in Grindavik, and I'm still hopeful that this will end well for them. We're seeing things trending in a good direction. I know that they'll make good decisions over there, but to me, it's also just a fascinating case study in just how to deal with not just a disaster, which they've already had, but a protracted disaster that might still pose a significant risk over a period of time. Like, what do you do? How do you manage that? And those are just really hard decisions. But this is a good place for this to be happening, in the sense that They value science. They work together collaboratively. This is a community that's going to, I think, make really good decisions. So we'll continue to monitor. Hopefully, we'll continue to see good indicators that folks can return to their homes sometime soon, and we'll just keep monitoring. So thanks so much for joining me. Be sure to like, subscribe, all those good things, and appreciate all your support and encouragement in making these. Appreciate that I'm able to help maybe my little opinions and perspective hopefully bring some clarity and maybe some peace of mind to people, especially those in Iceland. Um, just trying to do my part and share my thoughts with you. And if it's at all helpful, then that's great. So stay well and take care, and we'll see you next time. Thanks.